Bathurst Caribou herd of central northern Canada was once one of the largest migratory barren ground caribou herds in the world, and was estimated to number almost 500,000 animals during the late 1980s. Since then, the herd's size has declined dramatically, to the point where less than 10,000 animals remain. In 2022, population surveys estimated that the herd had declined to 6,200 animals, just a small fraction of its former size. The causes of this decline are not well understood. It is known that caribou herd sizes fluctuate naturally, but the magnitude of this decline is outside of any that has ever been observed by Dene or Inuit elders. Interestingly, many of North America's large migratory barren ground caribou herds declined during this same period. And although their declines weren't as large as the Bathurst herd experienced, it does suggest that there maybe is some common driver that's responsible for these trends. Climate change has been widespread across northern regions, and is one factor that all of these herds have experienced. In many areas, warming temperatures have resulted in thawing permafrost, reduced Arctic sea ice, and changes in seasonality, like earlier springs and later falls. One consequence of climate change that's been experienced in many Arctic and subarctic regions has been a recent change in vegetation. In areas north of tree line, this is often referred to as Arctic greening, which is in reference to the fact that tundra plant communities have experienced an increase in productivity, so they're growing more over the last couple of decades. As well, these communities have experienced an increase in the number and the amount of warm-tolerant species like shrubs. And in some regions even, we've seen an advance of tree line into the once treeless Arctic tundra. There's several different lines of evidence for these changes. One is simply the reports of people out on the land, observing more vegetation, thicker vegetation, inability to traverse the landscape either by foot or by snow machine because shrubs and trees have invaded these once treeless areas. Another line of evidence is repeat photography, where the locations of old photographs are rephotographed from the same angle and compared. And these really illustrate the extent and the type of change that's happened in the intervening years. More recently, satellite imagery has been used to track these changes on a global scale. There's particularly a useful tool for measuring change consistently through time over large or remote regions. And the results of this monitoring show a widespread increase in tundra plant productivity. Caribou are herbivores and rely exclusively on plants for their diet. In summer, the fresh shoots of grasses and green leafy vegetation are important dietary components. In winter, when herds migrate south, their diet shifts to take advantage of forest-growing lichens that they access beneath the snow. So given the importance of plants in the diet and in the migratory timing and migratory patterns of barren ground caribou, it certainly seems possible that changes in vegetation could have played a contributing factor in the demise of the Bathurst caribou herd. But the herd's range is huge. I mean, it spans the boreal forest all the way north to the Arctic Ocean. It's larger than the country of Germany. Understanding what's going on across that entire range is impossible from field data alone. And so we use satellite imagery to map changes in plant productivity on the Bathurst herd's range. There are hundreds of satellites in orbit around the planet. This animation illustrates the fleet of Earth-observing satellites operated by NASA, but there are many more operated by other agencies and corporations. On board these satellites are sensors that capture images of portions of the planet. The images are much like digital photographs, except that they record light in wavelengths well outside of what the human eye can detect. Because materials such as vegetation, ice, clouds, water, and soil all absorb and reflect light differently, these sensors are capable of detecting subtle differences in the Earth's surface not possible with a standard camera. These satellites all have different orbital speeds and altitudes and carry very different sensors, meaning that they each specialize in capturing a unique aspect of our dynamic planet. For this project, the team used imagery from a sensor called MODIS, carried on board NASA's Terra satellite. MODIS captures images of every part of the planet on a daily basis, which allows for a detailed understanding of how vegetation changes during the course of a year. So, we acquired MODIS imagery for a 22-year period, and we stacked each of these daily images on top of each other, virtually using a computer, and made sure they were all perfectly aligned, and then analyzed the trend for each pixel in that image over the 22-year period. We measured something called EVI, which stands for Enhanced Vegetation Index, and EVI is a measure of the amount of blue, red, and near-infrared light that a surface reflects. And it's just highly correlated with the amount of vegetation. So areas with lots of trees, high amounts of shrubs, they have high EVI. And areas with very little vegetation, rocks, water, etc., have very low EVI values. All of this analysis was used to generate a map of change in EVI from the year 2000 to the year 2021, which corresponds to that huge population decline that was experienced by the Bathurst herd. In the map, green indicates areas that have experienced increases in EVI over the 22-year period. The deeper the green color, the greater the increase. Brown areas experience decreases over that period. The darker the brown, the greater the decrease. The purple triangular shaped area represents the historical range of the Bathurst herd. The dashed black line is tree line, and the solid black line is the limit of continuous forest. Areas outlined in gray that are clustered toward the bottom of the map represent the perimeters of forest fires recorded since the 1950s. And what we see here is sort of a mixed bag of trends below tree line. There's increases, there's decreases. Some of them are really strong, some of them are more weak. But the boundaries of these areas align very closely with the perimeters of forest fires as mapped by the territorial government. So this shows that fire history really strongly influences trends in vegetation productivity. This is important for caribou because forested areas constitute that winter range. And lichen, which is the predominant food during winter, is slow to recover after forest fires. And with increasing amounts and size of forest fires, this could prove problematic for forage and food availability for caribou in the future. In tundra ecosystems north of the forest limit, the results show a predominant trend towards greening, or increases in vegetation production. Unlike the regions below tree line, there are very few areas where decreases were observed. Still, this increase did not occur everywhere, and some areas, shown here in white, did not change much at all. The tundra areas where greening was observed are comprised predominantly of low-growing shrub species, including species like Labrador tea, crowberry, cranberry, and taller species, including dwarf birch. Dwarf birch can actually shade out other species, like grasses that caribou tend to prefer during summer months. So even though we saw an increase in vegetation productivity, that might not be beneficial for caribou if it comes at the expense of species that are preferred forage. The team also used the satellite imagery to map changes in the length of growing season across the range. As with productivity, they found differences between the forested and tundra portions of the range, with trends in the forested regions being closely linked to fire history. In the tundra portion of the range, there was an overall trend toward longer growing seasons, especially in northern parts of the range. Interestingly, these trends were driven more by earlier springs than they were by later falls. And this appears to be due to trends toward earlier snowmelt in many areas. These are all changes that have been observed on parts of the Bathurst's range over the last few decades. Our use of satellite remote sensing did not discover vegetation change. Indigenous elders have been reporting these changes, biologists have been documenting these changes, and so forth. But the added value of the remote sensing data is that it provides a complete picture of these changes across the herd's entire range, not just a few points on a map. And in combination with caribou location data available since the late 1990s, these data can be used to understand how the vegetation changes have altered caribou habitat use during the same period. Despite its usefulness, there's only so much you can infer from satellite imagery. Eventually, you have to get out on the landscape and actually see what's going on to really understand these changes firsthand. So to that end, we've spent part of 3 summers traversing different parts of the summer range by canoe, stopping to study the vegetation at sites where the imagery indicated things had been changing the most. This included measures of shrub canopy cover to compare differences between sites that have changed a lot against sites where not much change was observed in the satellite images at all. We also sampled shrub stems to examine their annual growth rings. So just like trees, shrubs put on annual rings. And we examined these to determine how old the shrubs were and how fast they've been growing over the last several decades. We also conducted plant inventories to determine what species are growing in the areas that have increased in productivity and precisely how productive these communities are. Together, these 3 project components, satellite image mapping, field data collected at targeted locations, and analysis of caribou location data, are helping to provide an understanding of the role that vegetation change has played in the rapid decline of the Bathurst caribou herd.